Hi everyone, today I want to talk about why when you multiply two negative numbers, you end up getting a positive. Now, if you've never heard of this before, maybe you're just learning mathematics. I don't know what grade you're in. Great that you're learning mathematics. I applaud you and I hope that you go on to do great magical things in your math career. However, today we're just going to talk about this because for a lot of students it doesn't make much sense. Why do two negative numbers equal a positive? And to give you just an example, if you don't know what I'm really talking about, if I have negative 6 and I multiply it by negative 2, what do I get? Well, you might be inclined to say that it's negative 12, right? Because those numbers are negative, that one should be negative, but that's just not how this works. It turns out that this is 12. Okay, so negative 6 times negative 2 is 12. And if you just want to go by for the rest of your life that two negatives make a positive, great. If you can remember it, awesome. But if you want to know why, here's an interesting proof. And a proof in math is just proving that something that you're saying or a simplification you can make or something that you can do in math is really allowed. So why is this simplification allowed that we've asked here? And that's going to just be the scope of this entire video here is, well, why is that true? So let's get into it. We're going to just write out a simple little problem here. Okay, negative 2 times 6 minus 6. And when you look at this, just don't really compare the two yet. Yeah, they're the same numbers. There's a reason for that. We'll see. But don't think too hard about it now. What is this going to equal, do you think? Now, this might be a little complex math for you. Maybe, maybe not. But if it isn't, or if it is, I'll just walk you through it. Maybe you haven't gone there in your class yet. 6 minus 6. What is that? Whenever you have these complex terms, parentheses, you always have to do what's in the parentheses first. So in this case, we're doing 6 minus 6. Before we get to anything else, before we even think about that negative 2. Well, we know that this is going to be equal to negative 2 times 0. And do you remember the rule? Anytime you multiply by 0, and that's its own video, what happens when you multiply by 0? Well, your outcome is just 0. Okie dokie, so we have this statement here that negative 2 in parentheses 6 minus 6 is equal to negative 2 times 0, which is just 0. So I'm actually just going to simplify this as to not confuse a single person that this is true. So this statement is obviously true. We just proved it. Let's do a little bit of manipulation here to make things a little nicer. So I'm going to do an operation in algebra that you can do called the distributive property. Now what this does is says, okay, if I'm multiplying something in parentheses, I can multiply it to every added or subtracted term. So I can go like this. I can multiply in to both the 6 and the negative 6. So what I can say here is that, and I'm actually going to make this a little more elaborate. So in the black here, we're going to do negative 2 times 6. So negative 2 multiplied by 6. Okay? So that's the first part. We're just going to split this up here. I'm going to treat this a little differently. I'm going to say we're going to add here instead of subtract. And we're just going to make this plus negative 6. It's still the same thing. If you add a negative, you're still subtracting it. Does that make sense? So for example, if I have 6 minus 6, well, that's 0. If I say 6 plus a negative 6, you have to put the parentheses as to not confuse your operations. 6 plus negative 6, well, it's still as saying minus, so it's still 0. Okay, makes sense? Hopefully it does. We're just going to use that same logic here. We're going to add negative 6 multiplied by negative 2. Okay, so, oh, sorry, let me just change the color here. I forgot I was doing that to be quite honest. So we're going to say in green is this distributive property. So we're going to add that negative 6, and we're going to multiply it by negative 2. Okay? And we know that since the top equation in red here is equal to the bottom two little parenthesis containing pieces, that they're equal. Well, if this one here, if the red is equal to 0, what do you think that means for the bottom one? Well, it means it's also equal. I'm trying to think of an example here. If my dog came to me and said he was 15 years old in bark language, okay, let's say that's what this is saying. And then I speak to the vet and he confirms by like DNA evidence that my dog is 15, that's what this is saying. Now, maybe my dog's a pathological liar. I trust my dog. Whatever my dog says goes. So I'm going to believe both. That's what these functions are saying. There are different ways of expressing it, like your dog talking to you versus your veterinarian saying the same thing. It's still true, right? If your dog, although I should warn you, if your dog's talking to you, you might want to get yourself checked out. I don't know, that's just me. But anyways, let's get back to what we were talking about. I just wanted to make a little comparison for why we can say that this one is equal to 0. Now, what can we do here? Well, we can make a little bit of simplifications. Before we add these two, we have to actually know a single value of what it's equal to. So negative 2 times 6, well, a negative times a positive makes a negative. Hopefully you understand that idea, maybe through memorization. We know that this is going to simplify to negative 12. And we'll put it in parentheses here. And then we're going to add it to whatever this is. Now, assuming we don't know that this is going to output positive 12, because negative 6 times negative 2 is what we're referencing up here. If we didn't know this was 12, we're just going to put a question mark. We don't know. And we're going to say that this is equal to 0. Okay? Now, we have a equality. Okay? We're saying that negative 12, so negative 12 of something, plus some other number should equal 0. So how can we go about solving this? Well, if you know algebra, you could just move it to the other side and the question mark would be equal to whatever that is. But let's say you don't know that. Well, let's think about it. If I owe $12 to the bank, how much do I have to owe to make my account balance 0? So I took out a loan for $12. Never do that. I don't know why you ever would, but let's say you take a loan out for $12. How much do you have to pay the bank back to get to an account balance of 0? Well, you'd say 0, right? 12. You would say 12 because you took out a loan for $12. You have to pay back $12 to make all your ends holy again, right? To get back to 0, be a good man with a good credit score, right? So that means that this must be equal to 12. Our question mark here is equal to 12 to make this statement true. Therefore, if we work now backwards, saying that the question mark was negative 6 times negative 2, outputted a positive number, which was 12. Okay, so hopefully this idea made sense. If it did, please drop a like, comment, and subscribe if you learned something today. Now I apologize. I don't hope to like make anyone feel lesser of themselves. I know that maybe like you're just curious why two negatives make a positive. I wanted to make this video so you could see it from a very for the high-end people to understand, but also for the people that are just learning introductory mathematics. But thank you guys so much for watching. I hope that you have a wonderful day. Bye-bye.